Okay, so it's time to talk about Booleans. Booleans are simply true or false. You can think of them as a single bit. It is either 0 or 1, 0 being false, 1 being true. In Python, when we write them as literals, we capitalize them. So in code, a Boolean literal is either capital T true or capital F false. We have a collection of logical operators that will operate on Booleans. We have the logical operator and, or, and not. We also have quality and inequality. And then we also have bitwise operators, which you might wonder, well, like if a Boolean is only 1 bit, how is that different than these? And the answer is, well, it aside from some esoteric situations and how Python is implemented, they basically are the same. So I wouldn't even think about these. But they do exist and will work. Okay, let's look at the code. All right, we're going to set my Boolean to a Boolean literal true. And then we're going to say we assert that this is in fact true. Now I want you to just sort of walk through these assert statements and just convince yourself that each is true. And you'll notice that Python kind of reads a little bit like English here. True and true is true, false and true is false, false and false is false. That's kind of by design. There's a lot in Python that's sort of designed the way it is just to be sort of human readable in that way. We also have our negation operator here, not. And this is chainable, so we could say not true, which is in course true, because we're saying because not true is false, and then not false is true. And you might wonder here, okay, so not true is false. What's happening? Is it saying not true equals false and false is false? Or is it saying true is false and not false is true? There is an order of operations to Python, logical expressions and mathematical expressions, and you can look it up and see what it is, but I'm not even going to cover it, primarily because when reading code, it's really annoying to have to, if your expressions are at all complicated, it's really annoying to have to rely on your knowledge of what the order of operations of all the operators actually are. And so I find it's best to not even think about it. And if your code is at all ambiguous, use parentheses. And you can use these just like you can in grade school math to define the order of operations. So down here, we're just saying, okay, this is definitely going to be evaluated first, and then we're going to negate the result of this expression. Okay, the other thing to know about Booleans is that in Python, we can actually kind of treat them as the integer values of 0 and 1. So down here, notice we can say assert true equal 1. This equality, so we're saying that true is equal to 1 and false is equal to 0, and these will evaluate to true, of course. We can also actually add numbers to a Boolean. Adding a number to a Boolean will turn it into an integer. And this might be a little strange, like in other languages, many other languages you can't do this, but in Python you can, and you might see it occasionally. You might be looking at someone's code and be like, oh, well, I'm pretty sure that was a true false value, and then they're doing arithmetic with it. Well, sometimes people get clever and do this kind of thing. So just be aware that it is a possibility. Now let's actually do a breakpoint right here. IPB set trace. Let's start a terminal and enter into the code. So module 2. All right. So you'll notice I use equal here. True equal 1. Value is true. What happens if I use is? Oh, it's given me a syntax error. It's telling me that this isn't even valid. it's saying you can't use is with the literal. And since both of these are literals, this is wrong. Well, let me store these in values. Let's say what is my Boolean? My Boolean is true. Okay, let's say my int equal 1. My Boolean equal 1. My int should be true because my Boolean is true and my int is 1. What happens if we do my Boolean is my int? False. Again, we're going to get into is later, but the reason this is false is because these are not the same object in memory. So logical equivalence here, we want to use the equal, and we'll get into later much more granular detail of the difference between is and equal. Just know that when you are comparing variables to other variables for equality, and usually you're going to want to use equal. Is, leave it for instances with none when you're comparing to none. Okay, the other thing to know about logical expressions in Python is that they are evaluated lazily. What do I mean by that? I mean that Python, as soon as it knows that it has an answer and there is more left in the expression to evaluate that will not affect that answer, it is not going to do unnecessary work. So I have this example here. We have a variable. We are going to set it to none. Pretend this variable can hold either none or any integer number. And we have another variable that just says var is greater than 0. And so this is going to hold a Boolean value that corresponds to whether or not our variable is greater than 0. And none is not greater than 0. So when it's none, it should also be false. So we're going to go ahead and initialize it to false. And then we have this if expression. So, and you'll notice the greater than operator does not work on values that hold none. So what happens if we try to say none is greater than 0? We get an error, a type error. It says greater than is not supported between instances of none, type, and int. That just means this operator is meaningless when used on a variable that holds none or none itself. So if we got to this point in the code, our program would error out. So we want to avoid executing this expression if a variable is none. So we put this guard around it. We say if variable is not, only do this if our variable is not none. So if a variable holds an integer, then we end up evaluating is it greater than 0 and setting our variable here. Now, we can take advantage of this laziness optimization, this expression evaluation optimization, and combine this into a single if clause. And we can say if variable is not none and variable is greater than 0. Python is not going to evaluate both of these and then AND them together. It's going to evaluate this one first. And if variable is none, which it is right now, it is going to see that this expression evaluates to false. And Python is smart enough to know that false ANDed with anything else is going to be false. So as soon as it evaluates this expression and then evaluates this outer expression of and sees that the first value is false, it knows that it doesn't even have to do whatever this is. It can just go ahead and exit and return false as the result of this larger expression. So this is safe to do. When variable is none, we will never execute this expression. And so our program will never error out. You will see this kind of shorthand a lot in Python. It's more readable, and once you kind of get used to it, fewer lines of code can also often be more easily digested by your brain, so you will see it a lot. Now, notice we could also shorten this expression even further, and we can just say if variable and variable greater than 0, then we know our variable is greater than 0. And the reason we can do that is because when variable is 0, it will also evaluate to false. So when it's 0, this is false. And we exit out of our expression. We don't even have to say, is it greater than 0? Because we know if it's none or 0, it's not greater than 0. Now, this is just kind of a happy result of it's compatible with the second part of the logical expression. So be careful when you have like a none guard in one of your logical expressions. Just be careful that you might not be able to shorten it even further this way, because sometimes you will need to pass it through to this second expression if your variable is something other than none. And here's an example of that. I just want you to look at this and convince yourself that this is an incorrect if clause. Okay, there's one more sort of idiom in Python, or sort of shorthand assignment expression that you might see from time to time that is enabled by this lazy expression evaluation. And so I have this example here. Say we have a variable called x, and we want to assign it to one variable if that variable evaluates to true, and a different variable if the first variable evaluates to false. So we're going to set x to 0 if 0 is true, and x to 2 otherwise. And since 0 is false, this is what's going to be executed. So we're going to set x to 2. Because of this lazy expression evaluation in Python, we could actually just shorthand write this like this. We can say, we're just going to use a different variable here and say y is, we should assign y to 0 or 2. Python is going to evaluate 0 as a Boolean because it's part of this OR expression and see that it's false. And Python knows that false ORed with anything is going to be whatever the second value is. So false ORed with 2 here is going to be whatever 2 evaluates to. And since the result of this expression is not passed to another expression that would implicitly convert it to a Boolean, 0 or 2 is just going to return the value of 2. It's not actually even going to evaluate to a logical true or false value here. It's just going to return 2 out of the chain. And it's doing that because it's being lazy. It doesn't know, when it's executing this part of the code, this could be part of an outer expression, but it's not here. So 2 never gets implicitly converted to a Boolean. It just gets passed back to this assignment operator, and the assignment operator does not, implicitly convert anything to anything. So it's just going to set y to whatever this value is. So, if that's a little confusing, you'll kind of get the hang of it after you write some code. But this is a pretty common idiom that you will see in Python a lot. And just know that what's happening here is y is not being set to a Boolean. The result of this Boolean expression, it's being set to 0 if 0 is true, or 2 if 0 is false. And I have a further example here that you can go through and sort of convince yourself and see what's going on. So the last time we used the next command in our debugger to kind of step through the code. I want to show you one more thing that's useful here. So we jumped into our debugger when we ran this code by setting this breakpoint. Once you are in the debugger, you can set additional breakpoints at given lines of code. So let's say I want to go ahead and advance. Instead of hitting next a bunch of times and getting down here, I just want to go down to line 1. Let's do line 128. I can say break, just give it the line number. So now I have another breakpoint. It is like I wrote ipdb.setTrace here. I can just say, now I can just say continue, which is gonna continue the program until it hits another breakpoint. All right, so now I'm here, and I can see that X is defined, Y is defined. You can see here that when I do this, I don't get true, I get 2. And that's because of what we talked about. But if I were to say not 0 or 2, I'm going to get false because I'm nodding 2 here, which is going to be implicitly converted to a Boolean. All right.